Okie dokie. Boop, boop, boop. Okay. Let's do it. So I said, so how many more days do we have? We still kind of maybe have 7 days. So we're just gonna read this chapter. All right, we can do this. I'm gonna be pausing to talk a lot probably, but all right, let's move. Here we go. All right. Hello, my fellow risers. Okay. So, introduction. Um, you know what? I'm going to replace the batteries really quickly to this keyboard. I don't know how, but now I can't see it. What if I move it? So yeah, I would have to change my setup to and where so that if I wanted you to actually be able to see the text. But the weird because humans are weird, I think you're actually going to get something out of just being able to look at the page. Well, or you're going to feel like you are getting something out of it. All right, I'm going to go get batteries. Because, yeah, I don't think there's any way I could easily actually. Oh, and then I want to move that. Any way I could actually easily. Oh, that's good. That's how I should do it. give you a visual of the page. I don't think I could. Why am I? Oh, I see. Okay. All right. Good. Yeah. All right. Let me go replace these batteries. Okay. So chapter 1, section 1, introduction. It is a long tradition in Western philosophy to characterize humans as rational animals. Yeah, this is great. Love this. So, okay, introduction. It is a long tradition in Western philosophy to characterize humans as rational animals and to argue that rationality is one of the features that distinguishes them from other animals. It is not just Aristotle who describes the human as the rational animal in his metaphysics. In his Metaphysics, 1984. Okay, because that's just a recent publication. That's funny to put 1984. Is that not hilarious? In Discourse on the Method, in Discourse on the Method, 1985. Obviously not 1985 though. Descartes also characterizes humans in terms of their distinctive reason or understanding. Non human animals do not have reason at all. This trend has continued. Donald Davidson says that rationality distinguishes between the infant and the snail on one hand and the normal adult person on the other. Donald Davidson has some stuff that I really like, by the way. Hmm. Anyway, so this trend has continued. Donald Davidson in 1982. Oh, how did it continue if Aristotle said the other thing in 1984 and Descartes in 1985? This trend has continued. Donald Davidson says that rationality distinguishes between the infant and the snail on the one hand and the normal adult person on the other. This view, however, can be and has been challenged. One challenge is to deny the sharp contrast between human cognition, which is rational, and non human cognition, which is not. Humans are rational, but so are non human animals. Okay, or neither is. For example, Hume writes in his A Treatise of Human Nature, 2013, just kidding. For example, Hume writes in his A Treatise of Human Nature, oh, actually 2007. Well, at least here they put the actual date slash 2007. So, for example, Hume writes in his A Treatise of Human Nature that no truth appears to me more evident than that beasts are endowed with thought and reason as well as man. Hume, 1739 slash 2007. Another challenge, which is But so are non-human animals. That's interesting. I mean, yeah, they definitely have some what I call reasoning, which is like summarize. It's just like the mental form of reasoning. It's not real rationality. It's the brain's approximation. But it's really just a summary of what it's learned so far, kind of. Anyway, reasoning. So, for example, human blah blah. Okay. What did I want to underline? Yeah, definitely the beasts are endowed with thought and reason in the sense of like, oh, um, yeah, definitely. Yeah, definitely. They don't have full rationality. We don't either. That's not possible in a system, but in a, like a yeah, but mm, but they have a capacity for reason. They have reason approximate mechanisms. They have the proxies of reason. They have heuristics that have helped them survive, that get them to the reasonable conclusion in many situations that they faced along their evolution. Another challenge, which is the focus of this chapter, is to deny optimism about human rationality. Non human animals are not rational, but humans are not rational either. Great. Okay. You just said humans are rational, but so are non human animals. And you didn't say that somebody was saying that. All right, I gotta go back. So we talked about Donald Davidson. This view, however, that humans are rational animals and the beasts are not, this view, however, can be and has been challenged. One challenge is to deny the sharp contrast between human cognition, which is rational, and non human, which is not. And so then when you deny it, you say humans are rational, but so are non human animals. For example, Hume writes in his A Treatise of Human Nature that no truth appears to me more evident than that beasts are endowed with thought and reason as well as man. Another challenge, which is the focus of this chapter, is to deny optimism about human rationality. Non human animals are not rational, but humans are not rational either. In the memorable beginning of his essay, An Outline of Intellectual Rubbish, Russell wrote, "Man is a rational animal. So at least we have been told. Throughout a long life, I have searched diligently for evidence in favor of this statement. So far, I have not had the good fortune to come across it, though I have searched in many countries spread over 3 continents. Russellian pessimism about human rationality is echoed in a particularly influential psychological research program in the 20th century, the Heuristics and Biases Research Program led by Amos Tversky and Daniel Kahneman. Praise be. The studies in this program revealed systematic and severe errors in human reasoning, which seem to have a bleak implication for human rationality. These studies caused heated debates on human rationality, sometimes dubbed rationality wars. That's so funny because there's a debate between people who looked at that evidence and was like, "Oh, damn, okay," and people who looked at that evidence was like, "No, no." These studies caused heated debates on human rationality, sometimes dubbed rationality wars, both at the theoretical and conceptual level, both at the theoretical and conceptual level, and at the empirical and experimental level. The main aim of this chapter is to examine the relevant psychological studies to see if they really do have bleak or pessimistic implications for human rationality. We start by presenting a definition of rationality. Section 1.2. Before turning to the relevant psychological studies, in particular the ones from the Heuristics and Biases program, which reveal a systematic failure to reason according to the rules of logic, probability, and decision making. Section 1.3. The results of these studies support a pessimistic view of human rationality. Section 1.4. However, objections to the pessimistic interpretation were raised by Gerd Gigerenzer and his ecological rationality research program. Section 1.5. The objections from this program are significant because they bring to the fore important ideas that enhance our understanding of human rationality/irrationality. However, we shall argue that these objections do not refute the pessimistic interpretation. Although Gigerenzer's objections... Cool, bro. Although Gigerenzer's objections do not... Hey, Abbott, come here, hang out with me. Let Mama sleep. Come here. Kuche, down. Sit. No, down, yeah. That's a good sit. Now down. Yes, excellent. Good job, buddy. Great job. Hang out here with me. You're going to learn something. Watch this. Although Gigerenzer's objections do not refute pessimism, they lead us to examine an important issue: whether the difference between optimism and pessimism about rationality hangs on different accounts of the aim of cognition. Section 1.6. In the end, we defend a moderate form of pessimism, according to which humans are not as rational as we might have thought, before appreciating the results of the psychological studies on reasoning. Okay, section 1.2, clarifying rationality. Are humans rational? To answer this question, we need to investigate two sets of issues. One, what does it mean to be rational? What is necessary for a person to be rational? And what is sufficient for a person to be rational? The philosophical questions about rationality. Two, do humans satisfy a sufficient condition for being rational? Do humans fail to satisfy a necessary condition for being rational? And what do empirical studies say about these issues? The psychological questions about rationality. We discuss the philosophical questions in this section and the psychological questions in the next section. Rationality means different things in different contexts. We will focus on a narrow sense of rationality here. That is, rationality in the context of reasoning. In particular, we, tentatively, accept what Edward Stein, 1996, calls the standard picture of rationality, according to which rationality consists in reasoning in accordance with the rules of logic, probability, and decision-making. So, we have box 1A over here, see box 1A, so let's see it. Box 1A, the standard picture of rationality, because here's my definition of rationality. Here's my definition. My definition is correctly interpreting information and correctly combining that information with other correctly interpreted information to come to the indicated conclusion. So what that means is, first, there has to be an ability to receive the information. Secondly, there has to be an ability to give the correct weight to the information relative to the other pieces of information you're using. And then, third piece, to know which other pieces of information you're using. So to correctly receive information, to know which information is relevant, and then to give the relevant pieces of information the correct weights in your computation. And why that's impossible is because so even if the brain had just unlimited sort of processing power and blah, blah, it's still with novel stimuli, which there would be, in any equation, in any consideration, there's going to be some piece of information that you don't know what the weight should be for that information, what role that information should play, because you haven't been trained on it yet. Or actually, even if it's not a novel piece of stimuli, it still might be a novel combination of information that's appropriate. In which case, you don't know what the relative. Have I been saying relevant? I know I've been saying relevant for some things, but I've been saying relevant for everything. I meant to say relative weights should be for that set of for each item in that set of information. Um, and that's if the brain weren't the brain. If it were this infinite processor, it is not. So even the things it's been trained on, it can't store all the appropriate weights for every combination that it's experienced. And even if it could do that with the information, wait, hold on. Am I just repeating myself about if, um, yeah, and then even if the correct weights exist in here, they're not necessarily going to be recalled at the appropriate time, used. They're not going to be set up in such a way that they always play the role that they're supposed to play when they're supposed to play it. So hopefully that made sense. Anyway, so that's me. Now let's look at what Stein said, and because Miyazono-san is tentatively accepting what Edward Stein said. Okay, so the standard picture of rationality. Definition. According to this picture, to be rational is to reason in accordance with principles of reasoning that are based on rules of logic, probability theory, and so forth. Oh yeah, and it's not just the weights, also the operations. Yeah, which is kind of what they're referring to here. Yeah, it's also the operations. Like, should that be a biconditional? Should that be a conditional? Is that an exclusive or, etc. Hello? Okay. According to this picture, to be rational is to reason in accordance with principles of reasoning that are based on rules of logic, probability theory, and so forth. If the standard picture of reasoning is right, principles of reasoning that are based on such rules are normative principles of reasoning. Namely, they are the principles we ought to reason in accordance with. Example of deductive reasoning. Jesse believes that either Paula got an A in geometry or Vanessa did. And also that Vanessa did not get an A, but got a D instead. From these premises, Jesse concludes that it is Paula who got an A. Jesse is rational. Her logical reasoning is in accordance with a rule of logic that one can infer P from P or Q and not Q, a disjunctive syllogism. Example of probabilistic reasoning. Felix assigns the probability 0.8 to the idea that it will rain tomorrow based on the televised weather forecast that there is an 80% chance of rain tomorrow. Felix also assigns the probability 0.9 to the idea that it will rain tomorrow, and so he will go to the gym for a workout. Felix is irrational. His probabilistic judgment violates what is known as the conjunction rule. The probability of an event A occurring, P parenthesis A, or P of A, anyway, probability of A cannot be less than the probability of A and another event B occurring at the same time, P of conjunction A and B. What's the other event? Is this just a mistake? I don't get this. So he assigns a probability of 0.8 to the idea that it will rain tomorrow because what he saw on the Weather Channel. And he also assigns a probability of 0.9 to the idea that it will rain tomorrow. Something's missing here. Did they mean to say that, like, ah, ah, he assigns the probability of zero point 0.9 to the idea that it will rain tomorrow and that he will go to the gym. So zero point 0.8 chance it'll rain tomorrow, zero point 0.9 chance that it will both rain and I will go to the gym. Gotcha. I think that's written funny, but yeah, okay. So Felix also assigns the probability 0.9 to the idea that it will rain tomorrow, and so he will go to the gym for a workout. Ah, that it will rain tomorrow, and so he will go to the gym for a workout. That thing is 0.9. Gotcha. Yay. Okay, very good. Okay, so the last sentence that we had read was that we tentatively accept what Edward Stein, and I also accept this. Um, Great. Yeah, coincides with mine anyway. But how often should human agents reason in accordance with these rules to be considered rational agents? If the answer is always, then a rational person wouldn't be allowed to make any mistakes. This requirement is far too demanding. It is obvious that human agents are not rational according to such a stringent requirement. A realistic view would take into account the fact that rational agents can make reasoning errors, such as the occasional performance error that is attributed to some interfering factor, like lack of concentration. Okay, so that might be what the majority of people that are watching this think. Oh, yeah, we make mistakes. Sometimes we're not feeling well, whatever. But he's going to go on to say, yeah, but no, fundamentally, the process by which we come to conclusions is not by the principles of reasoning, the rules of logic, etc. So, a realistic view would take into account the fact that rational agents can make reasoning errors, such as the occasional performance error that is attributed to some interfering factor, e.g., lack of concentration. See box 1b. Oh. Okay, so we'll go back. So box 1b, competence versus performance. Great. But when we say humans are not rational, we're not just talking about performance. We're talking about competence, okay? But anyway, let's not get ahead of ourselves here. Great. When you attempt a task and fail, one of two things may be happening. Either you do not have the capacity to accurately perform the task due to some knowledge gap, or you have the capacity to accurately perform the task but fail to perform it accurately on a particular occasion due to external factors such as a distraction. Example: Gina and Tommaso were asked to calculate the square of 4. Got it. Right. The square of 4 by their teacher. Gina did not answer at all because she did not know that the square of a number is the number multiplied by itself. Gina lacked the competence to answer the question correctly. Tommaso answered 12. He knew how to make the square of a number, and he was familiar with the 4 times table, but he was distracted by a sudden noise outside the classroom and gave the wrong answer. Tommaso made a performance error. It's 2001. Chicago. The Latin school. Louisa, Brian, some other people are there for a math competition. We just finished the test. I come out and I say to Louisa, God damn it. I used, I don't know, I used pi r instead of pi d on problem 4. I used, instead of 2 pi r, I just used pi times the radius. She said, but no, you have to do 2 pi r. I said, no, I know. I just fucked it up. She goes, but then you didn't know then. Okay. So this is not an external thing. I wasn't distracted. The knowledge just didn't play the role that it was supposed to play. I don't know if he's going to talk about this, but there are definitely like times where knowledge can exist, But oh, I guess you're saying, oh no, no, he's okay. So the author would probably say, well, no, that's because of the external conditions. You were stressed about the test or whatever. That's why the mechanism didn't play the role it was supposed to play. Okay, so same thing. Um, okay, okay. So so anyway, so Tommaso answered 12. He knew how to make the square of a number and he was familiar with the four times table, but he was distracted by a sudden noise outside the classroom and gave the wrong answer. Tommaso made a performance error. When Cohen says that ordinary human reasoning cannot be held to be faultily programmed, he means that human reasoning competence is intact. Human agents can apply the rules of good reasoning in ideal conditions. Although reasoning performance may be imperfect, human agents may make errors in applying the rules of good reasoning due to external factors. Of course, we disagree with Cohen, and the author, I'm sure, does as well. So, a realistic view would take into account the fact that rational agents can make reasoning errors, such as the occasional performance error that is attributed to some interfering factor, e.g., lack of concentration. Saw box 1b. But they do not make systematic reasoning errors. Thus, rationality is compatible with occasional reasoning errors, but it is not compatible with systematic reasoning errors. The standard picture of rationality is accepted by many, perhaps most, philosophers, and reasonably so. After all, there is a key sense of rational that describes people who follow the rules of logic, probability, and decision making when they reason and solve problems. There are other senses of rational, of course, such as those that describe people who are not overwhelmed by their emotions when they make decisions, or those that describe people who support their arguments with evidence instead of merely stamping their foot in the debate. But rationality as logicality, as we might call it, is widely accepted in philosophy, economics, and psychology. For instance, Phil Gerrans says that a rational subject is one whose reasoning conforms to procedures such as logical rules or Bayesian decision theory, which produce inferentially consistent sets of propositions. And Richard Nisbet and Paul Thagard define rational behavior as what people should do given an optimal set of inferential rules. That's good. So first of all, Bayesian decision theory is just taking into account like your priors and the weight of new information that contradicts the priors, and then updating to have now a well posterior, which will become your new prior. Um, I like Richard. So of course I what do we mean rationality is logicality is widely accepted? Do we mean that it's that we accept that humans are that? I hope not. I don't think so because I mean that'd be a false sentence. That's not widely accepted in psychology. But so that, oh right, so it's just a definition. Okay, great, gotcha. Yes. And then we can define rational behavior as what people should do given an optimal set of inferential rules. We don't have an optimal set of inferential rules, but people whose behavior didn't match what a being would do with inferential, with a perfect set of rules, died. So we are the descendants of those who have heuristics that mimic an optimal set of inferential rules for some behaviors or for some situations. Having said that, not everybody agrees that the standard picture is the best understanding of human rationality. This controversy lies at the heart of the rationality wars between pessimists about human rationality, often appealing to the heuristics and biases program, and optimists about human rationality, often associated with the ecological rationality program. We will come back to this in section 1.5. There are some technical issues about the standard picture of rationality that we would like to mention briefly here. First, hold on, I haven't been underlining. Okay, so the first technical issue about the standard picture of rationality that we would like to briefly mention here is first, the standard picture seems to presuppose that there is just one system of logic, one theory of probability, and one set of principles for decision making. However, there are different formal systems of logic and different interpretations of probability. Even the principles of decision making can be disputed. Some rules of inference that are valid in standard logic, often called classical logic, are not valid in some non classical logical systems. This raises a question: which system of logic should be adopted in evaluating the reasoning performance of agents? This is especially tricky if reasoning performance is consistent with one system of logic but not with another. But not with another. Should we adopt the former and say that an agent's performance is rational, or should we adopt the latter and say that it is irrational? A similar issue arises when considering interpretations of probability. There are different interpretations of what probabilistic statements, e.g., there is an 80% chance that it will rain tomorrow, what these actually mean. There are also some probabilistic statements that make sense in some interpretations but not in others. This issue is relevant to the debate between pessimists and optimists. Gigerenzer, the most notable optimist, argues that some probabilistic questions in the heuristics and biases experiments are meaningless in light of his favorite interpretation of probability, which is known as the frequency interpretation. This issue will be discussed in 1.5. Second, the standard picture assumes that our reasoning should be evaluated against the standards of logic, probability, and decision making. And I bet he's going to say, but it probably makes more sense to compare it to survival. This implies that if our intuitive answer to a reasoning task is incompatible with a rule of logic, we should conclude that our intuition is at fault. But why can't we say that it is logic, not intuition, that is at fault? What? Second, the standard picture assumes that our reasoning should be evaluated against the standards of logic, probability, and decision making. This implies that if our intuitive answer to a reasoning task is incompatible with a rule of logic, that if our intuitive answer is incompatible with a rule of logic, then we should conclude that our intuition is at fault. But why can't we say that it is logic, not intuition, that is at fault? Oh, like the rule of logic, not the logic happening here. The rule of logic, like theoretically, the rule of logic, or the whatever I'm trying to say. the rule of logic might be wrong, and maybe our intuition is right. I say. In fact, the development of non-classical logic is sometimes at least partially motivated by some counterintuitive features of classic logic. I don't actually even know what non-classical logic is. This issue raises a further question. What should we do when facing an apparent discrepancy between logic and intuitive judgment? Should we trust logic and dismiss intuition as irrational? Or should we trust intuition and dismiss logic instead? Jonathan Cohen, another notable optimist, raises a similar issue. If the normative rules against which our intuitive judgments are evaluated are themselves evaluated on the basis of our intuitive judgments, then our intuition sets its own standards. But then, how can our intuitive judgment be irrational? How can our intuitive judgment deviate from the standards that are set by itself? Cohen adopts a radical conclusion that human irrationality cannot be proven in principle no matter what psychology shows. Ordinary human reasoning, by which I mean the reasoning of adults who have not been systematically educated in any branch of logic or probability theory, cannot be held to be faultily programmed. In making this claim, Cohen relies on the distinction between reasoning competence and reasoning performance. See box 1b again. Third, the standard picture presupposes that what matters to rational and successful reasoning is the conformity. Oh, now he's going to say what I thought he was going to say in the second section, I think. Third, the standard picture supposes that what matters to rational and successful reasoning is the conformity to the rules of logic, probability, and decision making. Not everybody agrees. For example, Keith Stanovich, and that's who came up with type 1, type 2, system 1, system 2, by the way, makes a distinction between rationality and intelligence, where rationality is a broader notion than in the standard picture, and intelligence is what the standard picture captures. In common discourse, intelligence and rationality are often conflated, or it is assumed that intelligence comprises rationality. But IQ tests do not measure the capacity for making good judgments and good choices that we commonly regard as a mark of rationality. If we take intelligence to stand for whatever IQ tests measure, then it does not tell us which behaviors are more likely to be conducive to the agent's well-being in real life. Whereas IQ tests measure the capacity to process and manipulate information quickly and efficiently, they are not sensitive to whether the agent forms beliefs that are well supported by the evidence or whether she can critically evaluate the information she receives. To illustrate this distinction, Stanovich describes famous cases of smart people who acted foolishly, by which he means that people who have high intelligence in some domain make bad judgments and bad choices, thereby behaving irrationally. This does not mean that intelligence is not worth studying, just that there are other things that we value. Intelligence and rationality can be seen as having different domains of applications. Stanovich, for instance, suggests that intelligence maps the efficiency of cognitive functioning at an algorithmic level, whereas his more comprehensive notion of rationality tracks thinking dispositions at a higher level, governs decision making, and takes into account the agent's goals and values. Some notions of rationality, like Stanovich's, are distinct from the standard picture, where rationality is associated with behavior that conforms to the rules of logic, probability, and decision making. So the agent's well-being in real life. So that's survival. What I'm thinking about now is, so Pinker had so Steven Pinker, rationality. So he had a good definition of rationality. that was different from mine, but you know, so then like what I was defining we can call logicality, and then I would want to accept Pinker's definition of rationality. I think it's useful. He convinced me. Anyway, I just want to throw this into definition 36 to 37. Um, a definition that is more or less faithful to the way the word is used is the ability to use knowledge to attain goals. Some notions of rationality, like Stanovich's, are distinct from the standard picture, where rationality is associated with behavior. So Pinker's would also be distinct. So, sorry, what is Stanovich's definition of rationality? I guess it's not unlike Pinker's, is it? Hey, Abbott, come here. Come here, buddy. Come. Yeah, and takes into account the agent's goals and values, right? Okay, very good. No, you're good, you're good. Yeah, good boys, buddy. Good boys, good boys, good boys, good boys, good boys. All right, let me see if it's not raining. But aren't you guys gonna get dirty? Hold on, Becca. Hold on. Okay, section 1.3, systematic biases and errors. Here is a tentative answer to the philosophical question with the qualifications we made at the end of the previous section. Rationality consists in reasoning in accordance with the rules of logic, probability, and decision making. Okay, so by that definition, no, we're not rational, is what the author is going to tell us, and I agree. Now, let us turn to the psychological questions. The crucial question is, do human agents actually reason in accordance with the rules of logic, probability, and decision making? We will now review relevant studies, mainly from the Heuristics and Biases program, which offer ample evidence that human reasoning systematically deviates from the rules of logic, probability, and decision making. They include some of the most famous results in 20th century psychological research. The Watson selection task. According to, by the way, so I'm going to be doing a video with this. So I made these. We have like one red. This can be anything. It's just there's something on one side and something on the other, and then you learn some rule, and then you have to figure out what to flip over. So then you're like presented like this, for instance. Maybe you're presented this, and we say that every card that has a 3 on it has brown on the back. So what do you need to flip over to check that rule? Okay, I'm not rational, but I think the correct answer would be to flip this one over. You don't need to flip this one over because the rule didn't say that only 3 has brown on the back. So, you know, you flip this over. Oh, look, brown. Great. Okay, so the rule holds. This doesn't make a difference. Okay, according to deductive logic, for a conditional statement of the form if P then Q to be falsified, the antecedent P must be true and the consequent Q must be false. So, So the statement, if you want to go to Brighton, then you need to catch the next train, is false if you do want to go to Brighton, but you don't need to catch the next train. The purpose of the selection task is to establish whether people can recognize when conditional statements are false. In the classic version of the task, Wasson, 1966, there is a deck of cards, and each of them has a number on one side and a letter on the other. Participants can see 4 cards on the table. The first has a vowel, A, on the visible side. The second, an odd number, 7. The third, a consonant, K. And the last, an even number, 4. Figure 1. Participants have to say which cards they need to turn to test the following rule. If a card has a vowel on one side, then it has an even number on the other side. Most participants in the classic version of the task said that the cards to be turned are the card with A on the visible side and the card with 4 on the visible side, or just the card with A on the visible side. However, the correct way to test the rule is to turn the card with A on the visible side and the card with 7 on the visible side, because a conditional statement is falsified when the antecedent, if a card has a vowel on one side, is true, and the consequent, then it has an even number on the other side, is false. Only 5% of the participants solved the selection task in this version. So, and the caption, this is important, says figure 1, Wasson selection task with abstract options. So not ones that like we've practiced sort of thinking about or we evolved to be good at thinking about. Great. And then figure 2, but this is in another 5 pages, is the Wasson selection task with concrete options. Great. Okay, conjunction fallacy. The next study involves the so-called conjunction fallacy, also known as the conjunction effect, which is a mistake people make when they assume that a statement describing the conjunction of two states of affairs, tomorrow it will be raining, and he should have done a callback here, so I think he should have put tomorrow it will be raining and I will go to the gym, but he didn't. Okay, so tomorrow will be raining and it will be cold is more probable than a statement describing one of those states of affairs alone. Tomorrow will be raining. Tomorrow it will be cold. In one experiment by Tversky and Kahneman in 1983, participants first read personality sketches of hypothetical people. First read, the Linderfeld group. First read personality sketches of hypothetical people and then answered questions about them. Participants were divided into 3 groups according to their background in probability and statistics. The naive group, those with no background. The intermediate, So the naive group, those with no background, the intermediate group, those with basic knowledge of probability and statistics, and the sophisticated group, those with advanced knowledge of probability and statistics. Here's the personality sketch of a hypothetical person. Linda. Excuse me. Linda is 31 years old, outspoken, and very bright. She majored in philosophy. As a student, she was deeply concerned with issues of discrimination and social justice, and participated in anti-nuclear demonstrations. I'm going to read that again because I want you to pay attention. It's probably 0 people here, but when the channel blows up, we're going to go back to this. I want you to read it again because I want you to actually answer this, okay? Okay, it's the only exercise we're doing. I'm lying. Others will come up, but you're not signing up to do all of them. You're just going to do this one for now, okay? Linda is 31 years old, single, outspoken, and very bright. She majored in philosophy. As a student, she was deeply concerned with issues of discrimination and social justice, and participated in anti-nuclear demonstrations. Please rank the following statements by their probability using 1 for the most probable and 8 for the least probable. Right, so you might not be able to do this, but yes, you can. Okay, pause it. Can you read that? Pause it. I'm gonna, well, or you can pause it after I'm done reading. Linda is a teacher. 1. Linda is a teacher in elementary school. 2. Linda works in a bookstore and takes yoga classes. 3. Linda is active in the feminist movement. 4. Linda is a psychiatric social worker. 5. Linda is a member of the League of Women Voters. 6. Linda is a bank teller. 7. Linda is an insurance salesperson. And 8. Linda is a bank teller and is active in the feminist movement. Well, now when you get it wrong, you're just going to blame the way I emphasized, which not totally unfair. So, okay, so pause, rank them. Oh, right. You're pausing, so I can just keep going. Because I pause when you pause, so that's okay. Okay. The result revealed that statements 3 and 7 were regarded, respectively, as the most probable and the least probable. So Linda is active in the feminist movement, most probable, according to subjects. And Linda is an insurance salesperson, least probable. Which is explained by the similarity of Linda's personality sketch with the stereotypical image of someone politically active, and the dissimilarity between her personality sketch and the stereotypical image of an insurance salesperson. Representativeness. The crucial statements to consider in this experiment are 6 and 8. The mean rank of the former, so 6, which was that Linda is a bank teller, was lower than the mean rank of the latter. Linda is a bank teller and is active in the feminist movement. Which means that Linda being a bank teller and active in the feminist movement was regarded as more probable than her being a bank teller. This, however, is a mistake. Linda being a bank teller and active in the feminist movement is the conjunction of her being a bank teller and of her being active in the feminist movement. And the conjunction cannot be more probable than one of the conjuncts. Thus, this mistake is an obvious violation of the conjunction rule. This fallacy was found in all 3 groups of participants, and background knowledge in statistics and probability did not have a significant effect on the participants' performance. Base rate neglect. So we've done conjunction fallacy, and we've done the Watson selection task, which is, I guess, like a conditional thing. So we're not good with conditions, we're not good with conjunctions, and we're not good with base rates. In another famous experiment led by Kahneman and Tversky in 1973, half of the Why is that so blurry? Does that help? In another famous experiment by Kahneman and Tversky, this one in 1973, so 10 years before the previous one, half of the participants read a story, cover story, which said that psychologists prepared 100 personality descriptions on the basis of interviewing and testing 30 engineers and 70 lawyers. Base rate. The other half of the participants read almost the same cover story, except that the numbers of engineers and the numbers of lawyers are switched. 70 engineers and 30 lawyers. So, boom, you're going to have some representativeness, and people should you read something that sounds a lot like an engineer, it should matter to you that only 30% of the stories are engineers. They should rate the likelihood that the thing that's representative of an engineer is actually from an engineer as less likely than those who read a cover story that 70% of the stories were about engineers. They should rate it as more likely that the story that was representative of an engineer was actually the story of an engineer. So some read that there's 30 engineers and that there are 100 personality descriptions based on 30 engineers and 70 lawyers. Other people read that it's based on 70 engineers and 30 lawyers. Then participants were presented with personality descriptions, supposedly randomly selected from the 100 personality descriptions, and were asked to judge the probability of that person being an engineer. Here's one such description. Jack is a 45-year-old man. He is married and has 4 children. Already I'm thinking lawyer. He is generally conservative, careful, and ambitious. He shows 20% battery. Where's the... This... Jack is a 45-year-old man, married, 4 children, generally conservative, careful, and ambitious. He shows no interest in political and social issues, and spends most of his free time on his many hobbies, which include home carpentry, sailing, and mathematical puzzles. Or representative of an engineer. I just follow the engineers don't have families. One finding was that participants made a judgment on the basis of the stereotypes associated with the 2 occupations, engineer and lawyer, which is consistent with what we saw in the Linda experiment. Linda was regarded as more likely to be active in the feminist movement, which nicely fits the stereotype provided in her personal description. Similarly, in this study, Jack was most likely, judged to be an engineer rather than a lawyer. Oh, no, that's what I ended up saying, right? Okay. I thought that's what I had said at first, right? Right, no, okay. Similarly, in this study, Jack was most likely judged to be an engineer rather than a lawyer because his personality description nicely fits the stereotype of engineers. The crucial finding was that the base rate information was largely neglected. The judgment was independent of the base rates provided in the cover stories. This error constitutes a violation of Bayes' rule, which says that the probability of a hypothesis H given an observation O, the posterior probability, is determined by both how likely O is if H is true, so the likelihood, and how probable H is without the observation, so the prior probability. For example, the probability of Jack being an engineer given the personality description is determined by both how likely the personal description, being generally conservative, careful, ambitious, etc., is if Jack is really an engineer, and how probable it is that Jack is an engineer without the personal description. What happened in the experiment, so you know that 70%, that this story has been randomly chosen from a set in which 70% of the stories are about engineers. Okay, so that's the prior probability, 70%. And then let's say you say that, oh no, let's say it's 30%. Let's say it's 30%. You're the one who's been told the base rate is 30%. And then, like, the probability that this is an engineer based on the personal description alone, or like how how the likelihood, as they called it, or like how representative the story feels, I guess. It's like, let's say it's 100%. Okay, but then your final answer isn't 100% because then it drops significantly because of the 30%. Now, I'm not a math guy, so I forget exactly what you're supposed to do, even though I think it's actually pretty simple. But so what happened in the experimental results was that the participants largely ignored the prior probability, i.e. how probable it is that Jack is an engineer without the personal description, which is determined by the base rate. Thus, Kahneman and Tversky summarized their finding as follows. One of the basic principles of statistical prediction is that prior probability, which summarizes what we knew about the problem before receiving independent specific evidence, remains relevant even after such evidence is obtained. Bayes' rule translates this qualitative principle into a multiplicative relation between prior odds and the likelihood ratio. Our subjects, however, fail to integrate prior probability with specific evidence. The failure to appreciate the relevance of prior probability in the presence of specific evidence is perhaps one of the most significant departures of intuition from the normative theory of prediction. Next, preference reversal. Another area of weakness in human reasoning can be found in the psychology and economics literature on preference reversals. What's that? The principle of procedure invariance tells us that given two options, if one prefers A to B, then this preference should not change when the method for eliciting the preferences changes. And you can change it with like framing. Oh, you can do like the mortality. What's framing? Oh yeah, here we go. 90%, 10%. Yeah, okay, great. Yet participants often state a preference for A over B when they are asked to make a direct choice, but are prepared to pay more to obtain B than they are to obtain A. Take two lotteries. A relatively safe lottery where one has a 10% chance of winning nothing and a 90% chance of winning £10. And a relatively risky lottery where one has a 10% chance of winning £90 and a 90% chance of winning nothing. If asked to choose, people usually prefer to buy a ticket for the safer lottery. In contrast, if asked no, I'm not reading. Hold on, let's see. Boop. 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 In contrast, if asked at what price they would sell their ticket, they set a higher selling price for the ticket of the risky lottery. This phenomenon is observed in different contexts of choice and matching, too. The classic example of the violation of procedure invariance in the literature is the traffic problem. All right, so 1. The Minister of Transportation is considering which of the following two programs would make the electorate happier. Program A is expected to reduce the yearly number of casualties in traffic accidents to 570, and its annual cost is estimated at $12 million. Program B is expected to reduce the yearly number of casualties in traffic accidents to 500, which is lower. The previous one was 570. And its annual cost is estimated at $55 million as opposed to $12 million for the 570. Which program would you like better? 2. The Minister of Transportation is considering which of the following two programs would make the electorate happier. Program A is expected to reduce the yearly number of casualties in traffic accidents to 570, and its annual cost is estimated at $12 million. Program B is expected to reduce the yearly number of casualties in traffic accidents to 500. At what cost would Program B be as attractive as Program A? Options 1 and 2 represent two different ways of eliciting people's preferences for one of the two life-saving programs. In option 1, participants are given all necessary information about the two programs, how many lives they would save, and at what cost. When preferences are elicited in this way, direct choice, 2/3 of participants express a preference for Program B. Oh, dang. I don't think we're going to be able to finish this. For Program B, which allows more lives to be saved at a higher cost. In option 2, I'm sorry, you're right. We should start that over. Okay, options 1 and 2 represent two different ways of eliciting people's preferences for one of the two life-saving programs. In option 1, participants are given all necessary information about the two programs, how many lives they would save, and at what cost. When preferences are elicited in this way, direct choice, 2/3 of participants express a preference for Program B, which allows more lives to be saved at a higher cost. In option 2, participants are told how many lives would be saved and the cost of Program A, but they are not told the cost of Program B. Rather, they are asked at what cost Program B would become as attractive as Program A. When the preference is elicited this way, price matching, right, because it's completely different mechanisms. Now that he uses the word matching, I get it. It's about like intensity matching. Is it? I don't know. When the preference is elicited this way, price matching, 90% of participants provide values smaller than $55 million for Program B, thereby indicating a preference for Program A. If we take the evidence concerning people's responses to the traffic problem as ecologically valid and reliable, and I just remembered what ecological means. Okay, it means that like it's you can like extrapolate the results to like real life. Is that right? Or that hmm. If we take the evidence concerning people's responses to the traffic problem as ecologically valid and reliable, it tells us something interesting. People have inconsistent attitudes about what the Minister of Transportation should do concerning the traffic problem. They believe that the minister should implement Program B to save the lives of 70 more people a year, even if the program costs $43 million more than Program A. They also believe that the minister should implement Program A, which would save fewer lives, unless Program B cost considerably less than $55 million. I wish you had told us like what the average price they gave for Program B would be. All you said is that 90% of them provided value smaller. But I guess now you're telling us that they provided values significantly smaller. Maybe 70% of people provided values significantly smaller. I mean, I bet they did. They probably, I mean, 55, that's more than 4 times. It's 4.25. It's 4.5 times as much money. I'm guessing people probably did like 1.25 times as much money because of like the numbers 570, 500. Um, so they believe that they should go with Program B, even though it's very dramatically more expensive. But they also believe that the minister should implement Program A, Because it costs, unless program B is much cheaper. Okay. Depending on the method by which the preference is elicited, participants seem to attribute different monetary value to human lives. Section 1.4, pessimism about rationality. So they gave us some great examples. What was the first one again? Oh yeah, we do poorly with conditional rules, conjunction, base rate, and then depending on how you ask the question, we're gonna reveal different preferences, different answers. Okay. Section 1.4, pessimism about rationality. Making sense of the results. Overall, these studies reveal systematic and severe errors in human reasoning that have a bleak implication for human rationality. They provide powerful empirical support. For the pessimistic conclusion about human rationality that human agents systematically fail to reason in accordance with the rules of deductive reasoning, such as in the Watson selection task, or in accordance with the rules of probability theory, such as the conjunction rule, the Linda experiment, or Bayes' rule, the Jack experiment. Moreover, participants violate basic principles of decision-making, procedure invariance, and description invariance, and change their preferences depending on the methods by which their preferences are elicited and the way in which options are presented. According to Kahneman and Tversky, systematic failures in human reasoning are due to the fact that human agents do not rely on the rules of logic, probability, and decision making that would guarantee accuracy, but rather rely on heuristics. Heuristics are cognitive shortcuts or cognitive rules of thumb that reduce the complex tasks to simpler judgmental operations. Tversky and Kahneman, 1974. Heuristics are reliable in many cases, especially in those cases where heuristics and the rules of logic, probability, and decision making deliver the same answer. However, in other cases, heuristics can lead to systematic errors and deliver different answers from those one would arrive at by applying the rules of logic, probability, and decision making. In making a heuristic judgment, you replace a difficult question with an easier one and answer that question instead. Substitution. For example, the question, how far is the mountain over there from here, is a relatively difficult question, which, if you want to answer it in a canonical way, requires you to find a map, identify your place on the map, identify the mountain on the map, measure the distance between them on the map, and then calculate the actual distance while taking into account the scale of the map. Instead of answering the difficult question, you can substitute it with another question. How clear does the mountain look to me? Which is a lot easier to answer. When it looks very clear to you, for example, you can conclude that the mountain is very close to you, or, how big is it? This substitution strategy works in many cases, but it inevitably leads to systematic errors in other cases. For example, distances are often overestimated when the contours of objects are blurry and are underestimated when the contours of objects are sharp. Similarly, it is not easy to answer probabilistic judgments such as what is the probability of Linda being a bank teller, or what is the probability of Jack being an engineer. However, instead of answering these questions, one can substitute them with questions of similarity, which I think is just offensive that he put similarity. Oh, he's going to say the word representativeness in a second. Okay. However, instead of answering these questions, one can substitute them with questions of similarity, which are a lot easier. How is Linda's description similar to that of a stereotypical bank teller? Or how is Jack's description similar to that of a stereotypical engineer? The substitution in this case is known as an application of the representativeness heuristic, in which probabilities are evaluated by the degree to which A is representative of B, that is, by the degree to which A resembles B. Can you imagine if I'm not live? Great. Great. Fantastic. Super. But why don't there's not even a 0 for the views. It's like, I'm gonna refresh this page here. It's just not even filled in. Great. I mean, there's a 0 for the views on this video, but when I read the introduction to this book, okay. Where are we? I'm just reassuring myself. Because, Mr. Beast just counted to 100,000. So, I'm over here thinking, oh, I got 0 views. That means I'm like a bad philosopher or some shit, which is just such a crazy conclusion, um, given that there are so many other factors. And also given that stream audiences aren't determined by how good of a philosopher the person is or how good at anything the person is, really. Or even how entertaining it is, really. I don't know. Anyway, okay. Carrying on, please. We can do this. What is it, 40 or 45 that we have to get to? 45? Alright, we can do this. We can do this. We're just gonna knock this out, bro. Because there's no point talking about it if there's nobody here. But reading it, I gain from that. Okay, great. Alright, here we go. I'm not gonna say another word for the next. I'm gonna not to say another word for the rest of this section. I promise. I'm not gonna say another word of my own for the rest of this section. Okay. However, instead of answering these questions, one can substitute them with questions of similarity, which are a lot easier. How is Linda's description similar to that of a stereotypical bank teller? Or how is Jack's description similar to that of a stereotypical engineer? The substitution in this case is known as an application of the representativeness heuristic, in which probabilities are evaluated by the degree to which A is representative of B, that is, by the degree to which A resembles B. The representativeness heuristic works in many cases, but it inevitably leads to systematic errors in other cases. For instance, it leads to the violation of the conjunction rule when participants are asked to compare the probability of Linda being a bank teller with the probability of Linda being a feminist bank teller. When the similarity between Linda and a stereotypical bank teller and the similarity between Linda and a stereotypical feminist bank teller, when participants rely on the representativeness heuristic, they compare the similarity between Linda and a stereotypical bank teller and the similarity between Linda and a stereotypical feminist bank teller. Since Linda is not similar to a stereotypical bank teller at all, participants come to the conclusion that Linda is more likely to be a feminist bank teller than a bank teller, which is mathematically fallacious. Kahneman and Tversky claim that reasoning errors are systematic and severe, but this does not mean that they are unavoidable. A finding is that the conjunction effect is reduced by asking about the frequency of an event, how often the event occurs, rather than its probability, how probable it is that the event will occur. A study by Klaus Fiedler in 1988 compared two versions of the Linda experiment. The original version, probability, which asks the probability of Linda being a bank teller and of her being a feminist bank teller, and a new version, frequency. Klaus Fiedler, in 1988, compared two versions of the Linda experiment. The original version, probability, which asked the probability of Linda being a bank teller and of her being a feminist bank teller, and a new version, frequency, which instead asks how many people out of 100 who fit Linda's description are bank tellers and how many are feminist bank tellers. Participants are much more likely to give the correct answer to the new frequency version of the task, 78% correct answer, than to the original probability version, 9% correct answer. Similarly, other versions of the Watson selection task were devised based on the hypothesis that performance improves when the rule that is tested is more concrete and refers to situations that participants experience in everyday life. Indeed, there was significant improvement in the results. In one version, the following statement was tested. Every time I go to Manchester, I travel by car. Participants were presented with 4 cards that showed on their open sides one of the following: Manchester, Leeds, car, and train. Figure 2. Watson selection task with concrete options. On this occasion, 2/3 of participants were able to choose the right pair of cards to turn to test the rule, the correct pair being the cards with Manchester and train on the visible sides. These performance improvements will be an important issue in our later discussion. Argument for pessimism. The psychological experiments on reasoning seem to support the pessimistic conclusion that humans are vulnerable to systematic and widespread irrationality. According to the experimental results, people exhibit poor reasoning performance in a number of tasks, including logical, probabilistic, and decision-making tasks. The conclusion drawn is that people do not reason rationally in those circumstances. The evidence indicates that people make inferential errors. The errors seem to be due to lack of knowledge of certain inductive rules or an inability to apply them. If so, then people are not fully rational in that their inferences fall short of the best available normative standards. Thagard and Nisbet, 1983. We argue that the deviations of actual behavior from the normative model are too widespread to be ignored, too systematic to be dismissed as random error, and too fundamental to be accommodated by the theory of rational choice, and then show that the most basic rules of the theory are commonly violated by decision makers. Tversky and Kahneman, 1986. The argument for pessimism goes as follows. We provisionally answered the philosophical questions by adopting the standard picture of rationality, according to which to be rational is to reason in accordance with the rules of logic, probability, and decision-making. Back in section 1.3. Then we moved on to the psychological questions and saw that human reasoning systematically deviates from the rules of logic, probability, and decision-making in section 1.4. Putting the philosophical and psychological discussions together, we reach a pessimistic conclusion about human rationality. We now turn to the objections to pessimism, in particular the objections from the ecological rationality program led by Gigerenzer. As Kahneman and Tversky note, Gigerenzer's objections include 2 claims: a conceptual argument against our use of the term bias, and as Kahneman and Tversky note, Gigerenzer's objections include 2 claims: a conceptual argument against our use of the term bias, and an empirical claim about the disappearance of the patterns of judgment that we had documented. Kahneman and Tversky, 1996. Gigerenzer's empirical claim is related to the psychological part of the argument for pessimism. Gigerenzer interprets the psychological studies differently, emphasizing the fact that reasoning performance can be improved when the problems are formulated in a different way. As we saw above in the frequency version of the experiment run by Fiedler, participants' performances improved significantly. Notice that the proponents of the heuristics and biases program and the proponents of the ecological rationality program both recognize the possible performance improvements. Gigerenzer tends to stress the fragility of biases. He says that the biases disappear. Kahneman and Tversky, in contrast, tend to stress the robustness of the biases. They say that biases can be reduced by targeted interventions but cannot be made to disappear. But it is far from obvious that this is more than a difference in emphasis or rhetoric. Indeed, Kahneman and Tversky write, there is less psychological substance to Gigerenzer's disagreement with our position than meets the eye. 1996. A more substantial and philosophically interesting disagreement concerns Gigerenzer's conceptual argument, which is related to the philosophical part of the argument for pessimism. He rejects the standard picture of rationality, or at least the way in which the standard picture is used in the argument for pessimism. He does not think that reasoning performance should be evaluated in terms of the rules of logic, probability, and decision-making. Among Gigerenzer's conceptual or philosophical objections, we focus on three main objections, which we discuss in turn in the next section. I can't promise jack shit about this section, bro. Here's what I can promise. I can promise something. I will stop reading and say something one time per page. Okay. Objections to pessimism. Section 1.5. Objections to pessimism. The feasibility objection. According to the first objection, what we call the feasibility objection, systematic failures to reason in accordance with the rules of logic, probability, and decision-making do not necessarily imply irrationality, because it is unfair and unrealistic to evaluate human reasoning performance in terms of such rules in the first place. As we noted, the argument for pessimism is based on the standard picture, according to which rationality consists in reasoning in accordance with the rules of logic, probability, and decision-making, such as the conjunction rule, Bayes' rule, and the principle of descriptive invariance. But it would be unfairly simplistic and demanding to evaluate human reasoning in terms of the rules of logic, probability, and decision-making. As Gigerenzer notes, such an unfair and unrealistic evaluation ignores the constraints imposed on human beings. A constraint refers to a limited mental or environmental resource. Limited memory span is a constraint of the mind, and information cost is a constraint of the environment. Indeed, not everybody agrees with the claim that standards of good reasoning should be derived from the rules of logic, probability, and decision-making. So I might as well use my comment. And so what I'm going to say is, absolutely, I endorse the feasibility objection. The only reason I even say, we're not rational in the sense of we don't reason in accordance with the rules of logic, probability, and decision making is because you think that you do. Now, if we can relinquish that, then we can, redefine rationality as something that some people actually emulate. Some people actually, use, do, whatever. And that can be like pinkers using information in order to attain a goal. How well you use information to attain a goal or something. Yeah. Um, some philosophers, e.g., Harman in 1999, have argued that human thought should have independent normative standards that reflect human cognitive capacities and limitations. In their accounts, normative standards of rationality are not modeled on formal principles of logic, probability, and decision theory. Let us consider an example. The standard picture would demand logical consistency among a person's beliefs, which means that a person should not have beliefs that are logically inconsistent with one another. However, the task of maintaining a logically consistent belief system is extremely demanding given realistic computational constraints. The job requires greater computational resources than those available to human cognitive systems. As Stefan Stich puts it, perhaps evaluating human reasoning in terms of the standard picture might be committed to the perverse judgment that subjects are doing a bad job of reasoning because they are not using a strategy that requires a brain the size of a blimp. Stitch, 1990. The feasibility objection certainly raises a fair worry about the standard picture in its idealized form. That is, rationality requires reasoning perfectly in accordance with the rules of logic, probability, and decision making. The standard picture needs to be weakened in light of computational and other relevant constraints, although it is not easy to distinguish relevant constraints from irrelevant ones. See Stitch, 1990. In this vein, Christopher Cherniak argues against upholding logical consistency as an ideal of rationality for human belief systems and endorses a less demanding version of the standard picture of rationality that includes feasibility considerations. He calls it minimal rationality. According to the dictates of minimal rationality, for a belief-like state to be minimally rational, it must conform to standards of correct reasoning that are feasible in light of the limitations of human cognitive capacities. For purposes, the normative theory is this. The person must make all and only feasible sound inferences from his beliefs that, according to his beliefs, would tend to satisfy his desires. For our purposes, the normative theory is this. The person must take all and only feasible sound inferences from his beliefs that, according to his beliefs, would tend to satisfy his desires. All and only feasible sound inferences from his beliefs that would tend to satisfy his desires. However, the pessimistic argument cannot be avoided even when computational constraints are taken into account. It would not be fair to expect that rational agents maintain a perfectly consistent belief system when computational constraints are taken into account. However, even when the constraints are taken into account, my comment for this page is going to be great. I did repeat the Cherniak quote a couple of times to make sure that we got it. Was not repeating when I was back to my normal voice. I'm gonna repeat it now just so, because look, I love the author. I don't love his authorship. However, the pessimistic argument cannot be avoided even when computational constraints are taken into account. It would not be fair to expect that rational agents maintain a perfectly consistent belief system when computational constraints are taken into account. However, even when the constraints are taken into account, It would be fair to expect that rational agents do not make particular errors and mistakes, such as the error of assigning a higher probability to Linda being a feminist bank teller than to Linda being a bank teller. After all, in all of the experiments discussed above, some participants do offer the logically or mathematically correct answer, and they do not have a brain. A brain the size of a blimp. Stanovich, 1999, empirically examined this issue by studying the relation between computational capacity, measured by SAT scores, and reasoning performance in reasoning tasks. He found a moderate positive correlation between computational capacity and reasoning performance, but concluded that the computational limitation is responsible only for part of the reasoning failures. If correct, this supports the idea that reasoning errors that are found in the heuristics and biases research have little to do with computational constraints. Thus, computational constraints cannot be an excuse for their reasoning errors. I think I'm going to use my comment now. Earlier, I was talking about why I talked about why theoretically and concretely pure rationality, the standard picture, is impossible. Like, first of all, no system, even an infinite one, could be prepared for novel stimuli or combinations of information, for novel information or combinations of information. And then two, we don't have the computational power. Okay. But I want to also say that, yeah, those aren't the only reasons that we're not rational, according to Eris. There's also just that it didn't like make sense. Like it costs too much to be rational, to evolve rationality. It was just extremely unlikely, and it didn't happen. Um, I mean, even something sort of like approaching the standard picture, just approaching it, I guess. Um, no, instead it was just like whatever brain mechanism got you doing the thing that is good to do, even if you're not doing it for the reason that it's good to do, even if you didn't do the computation that a logical angel would do to get to that solution. If, however, you getting to that solution, the fact that you're getting it, you win. You get to reproduce and have children. Okay? And those are the heuristics. I don't care by hook, by crook, or by heuristic, by fallacy, by bias, however you do it. It's favored if it's getting done. The meaninglessness objection. The Linda experiment and other probabilistic tasks in the heuristics and biases program ask participants boom, just gave my stream a like. I'm gonna have it running too. Right. Alright, now I feel a little less lonely. The meaninglessness objection. The Linda experiment and other probabilistic tasks in the heuristics and biases program ask participants. Just got a second like. Hello. Are you, mama? The Linda experiment and other probabilistic tests in the heuristics and biases program ask participants to assess the probability of a single event, e.g., the probability of Linda being a feminist bank teller, However, according to a frequentist interpretation of probability, it is hard to make sense of the probability of a single event. According to the simple frequency interpretation, a claim about the probability of an event, e.g., the probability of winning a coin toss is 0.5, is understood as talking about the frequency of the event relative to the relevant reference class, e.g., the frequency of winning relative to the total number of tosses of that particular coin. The Linda experiment asks the probability of Linda being a feminist bank teller. On a frequentist interpretation, this amounts to asking the frequency of Linda being a feminist bank teller. What does that mean? The frequency of Linda being a feminist bank teller relative to the total cases of her being a feminist bank teller in her life would be 1. Does that mean then that the probability of Linda being a feminist bank teller is 1? Gigerenzer's objection is that asking the probability of a single, non-repetitive event, like Linda being a feminist bank teller, is an ill-formed question. Since the question is ill-formed and meaningless, there is no correct answer to it. Thus, it is not a mistake to assign a higher probability to Linda being a feminist bank teller than to Linda being a bank teller. The philosophical and statistical distinction between single events and frequencies clarifies that judgments hitherto labeled instances of the conjunction fallacy cannot be properly called reasoning errors in the sense of violations of the laws of probability. Moreover, as we've already seen, Fiedler, 1988, when questions are explicitly framed in the format of frequency with a clearly specified reference class, among the 100 people who fit Linda's description, how many are bank tellers and how many are feminist bank tellers, participants' performance improves. This reveals that people make apparent mistakes when the question is ill-formed, asking the probability of a single event with no specified reference class. But do not make mistakes when the question is well-formed, asking the frequency of something being the case among a specified reference class. It would seem then that people are far from being irrational. What we call the meaninglessness objection can be developed in at least 2 ways. In other words, there are at least 2 versions of it. The first version, the factual version, states that the frequency interpretation of probability is true as a matter of fact, and hence the probabilistic questions in the heuristics and biases experiments are nonsense as a matter of fact. The second version, the psychological version, states that frequentism is psychologically true in the sense that the information about probability is represented in the frequentist format in the mind of human agents. Hence, the probabilistic questions in the heuristics and biases experiments are nonsense psychologically, i.e., the participants cannot make sense of the questions. The factual version of the meaningless objection is philosophically bold. It presupposes the truth of the frequency interpretation of probability. The interpretation of probability is a highly contested topic in philosophy, which goes beyond the scope of this book. But it is worth pointing out that the factual version involves a controversial argumentative strategy. After all, the simplistic version of frequentism has been criticized exactly because people think that they can meaningfully talk about the probability of a single event. It is true that the probability of a single event does not make sense according to frequentism, but it only shows that frequentism is problematic. I don't think I have anything to say, but I'm pretty sure I'm following. I'm not positive though. The probability that I'm following is 100%. But the frequency that our brain in this position reading this thing out of 100 cases is following probably 70 times. I think that was clever what I just did. The psychological version of the meaningless objection is less bold than the factual version. Unlike the factual version, the psychological version is not committed to a particular claim about the interpretation of probability. The problem with the psychological version, however, is that it is not bold enough. The psychological version of the meaningless objection is less bold than the factual version. The psychological version of the meaninglessness objection is less bold than the factual version. Unlike the factual version, the psychological version is not committed to a particular claim about the interpretation of probability. The problem with the psychological version, however, is that it is not bold enough. If frequentism is not true as a matter of fact, but is merely true psychologically, then the probabilistic questions do make sense as a matter of fact, and thus reasoning biases are real errors as a matter of fact after all. I'm saying I understand, not that I agree. But I think I also agree, but mainly I was just trying to communicate, okay, now I get it, what's going on. Okay. The psychological version is psychologically problematic as well. It is unlikely that the probabilistic questions in the Linda experiment are psychological nonsense. Apparently, participants do not regard the questions as nonsense. After all, they provide meaningful answers to the questions in the experiments rather than refusing to answer or demanding clarifications. I don't want my last comment to count. I'm going to make my comment now. Just whatever, because I said so. Last comment doesn't count. It's just like just clarifying a little something about a face I made. I disagree with this. You can provide meaningful answers even if it came in as nonsense. That wouldn't surprise me at all. I'm sure there are currently experiments where you like ask someone kind of a nonsense question and they just substitute and then respond to another question that was a little bit like the nonsense question. But yeah, rather than just like glitching and going, oh, I don't understand what's going on, they just go, all right, here's what I will tell you. But thinking that they are responding to the original question, because substitution, it's a system one thing. The ecological rationality objection. The next objection directly confronts the standard picture of rationality, which defines rationality in terms of the rules of logic, probability, and decision making. This seems to be where Gigerenzer's fundamental disagreement with pessimists lies. As Gigerenzer notes, his main disagreement with the pessimism in the heuristics and biases program is that it does not It does not question the norms of logic and probability themselves, and it retains the norms and interprets deviations from these norms as cognitive illusions. The standard picture is problematic according to Gigerenzer. Humans have, e- Humans have evolved in natural environments, both social and physical, to survive, reproduce, and evolve. The task is to adapt to these environments or else to change them. The structure of natural environments, however, is ecological rather than logical. The problem identified by Gigerenzer is that the standard picture neglects the role of environment, which is a crucial factor for biological success. As an alternative to the standard picture of rationality, Gigerenzer offers the ecological picture of rationality, which characterizes rationality in terms of cognitive success in the relevant environment. According According to the standard picture, rationality requires a fit between the mind. According to the standard picture, rationality requires a fit between the mind and the rules of logic, probability, and decision making, while ecological rationality requires a fit between structures of information processing mechanisms in the mind and structures of information in the world. Baby doll, the boys had muddy paws, so I know you like to sometimes wipe those. So I want to let you know that that's the situation before he touches your blanket. Yeah, so attentive, right? Great. Get ready and leave us? Seriously gonna leave us, bro? He does. He does. He does. Yeah, so I was thinking that I would cuz I was thinking that you're gonna be there until 45 when the workday ends, but not necessarily, right? Huh? Oh. Oh, so that I see. I thought time had I had been pretty I had read pretty quickly. Ah, now it's updated because this was saying 5:15. Got you, got you, got you. I was trying to. Oh man, I was really thinking I had a really good chance getting done by 5:45. I don't think I have a good chance anymore. Um, yeah. I mean, and also, I mean, the paws are probably dry by now, so you probably don't even need to clean them. Great. Okay. Oh, darn, I really wanted to hang out with you while you're getting ready. But I do want to finish this chapter. Okay, so that's what's happening. But I can finish before you leave. Okay, here we go. Um, like when are you leaving? How much time do you think? At 20 minutes? Okay, great. All right, here we go. So we were saying that according to the standard picture, rationality requires a fit between the mind and the rules of logic, probability, and decision making, while ecological rationality requires a fit between structures of information processing mechanisms in the mind and structures of information in the world. When we evaluate human reasoning performance in light of the ecological picture rather than the standard picture, the pessimistic interpretation is no longer warranted. For example, the information about probability available in the ancient environment was represented in the frequency format, e.g., 3 rainy days in 10 days, rather than 30% chance of rain. As we have seen, human reasoning performance is relatively good when the questions are represented in the frequency format. Thus, human probabilistic reasoning seems to be ecologically rational. It worked successfully in the ancient environment in which probability was represented in the frequency format. Okay, but that's one example. A similar argument can be made about the Watson selection task. One might speculate that information about cheaters, those who receive the benefit of cooperation without contributing to it, was particularly salient in ancient societies. Indeed, failing to detect cheaters is a serious challenge to the maintenance of altruistic behaviors. It turns out that the Watson selection task becomes less challenging when the content of the statement to be falsified is an example of a social exchange rule. Alternative versions of the selection task were devised to test the hypothesis that a participant's performance improves when the statement tested is a cheater detection rule. For instance, Richard Griggs and James Cox in 1982 asked participants to imagine a police officer checking whether people drinking in a bar respect the following rule. If you drink alcohol, then you must be over 21 years of age. The cars had on their visible sides one of the following: beer, Coke, 22, 16. In this situation, the majority of participants correctly chose the beer card and the 16 years card. It could be argued then that human deductive reasoning is ecologically rational. Yeah, in this fucking example, bro. But our environment's pretty fucking different. The demands are pretty freaking different from what we adapted to, right? And as you know, in other videos, I've talked about the adaptable you, because I'm the only one here. So, as you know, there's the adapted period, which is the period where sort of, our nature, our function is more or less adapted to the environment, where it's, more or less reliable. I would not call, yes. No, I would not call today reliable. There's so many people that can't feed themselves, bro. So obviously we're in a demand period where we haven't yet adapted to the demands. And the demands are moving so fast, there's no way we're going to catch up. So, anyway, a similar argument can be made about the was, and we've done that. In effect, Gigerenzer introduces an alternative conception of rationality, namely the ecological. Okay, I guess there have been there's been no time when everybody could feed themselves. Okay, true. So, what could be I guess we could ask ChatGPT, how many people can't feed themselves in 2026? And of course, we have to define that. Okay, I think it's still an interesting concept, this idea that there are times where our environment is like really demanding, in the sense of it demands things that we are not really prepared to give. And then there are times when there's a little bit more of an equilibrium, where we are able to we are adapted to the, demands. But this is definitely not fucking that. This is like this. What about raising kids? We have single parent families. We do not have the mechanisms for that. So the single parents are really, really struggling because they're not, in a tribe where their child rearing responsibilities are shared. And the kids are really suffering that. Also socially, we're really suffering. We're not like surrounded consistently by the same people. And so we have to like be wary of everybody because we haven't really built up relationships. If we haven't, like, for instance, who are the nearest people to me right now? Okay, so Sarah, I'm lucky. I met Sarah in third grade. Okay. Most people, partner, they did not meet in third grade. Okay. The next closest person is a woman over there that I've spoken to once. We have spent weeks now within 20 feet of each other. I just saw her. Just walked. She just turned on the light in her kitchen. She's at the sink. Okay, I see her often. I can tell you her name, the name of her boyfriend, and that is it. Okay? That's weird. Um, you're supposed to know the people that you see. Okay? All right, we'll leave it there because, okay, let's go. In effect, Gigerenzer introduces an alternative conception of rationality, namely the ecological conception of rationality, and argues that human reasoning meets the requirements of ecological rationality. Thus, we seem to have two conceptions of rationality that yield two different interpretations of the experimental results. Our conclusion is pessimistic. Humans are irrational. Oh, our conclusion is pessimistic. Humans are irrational when human reasoning performance is evaluated in light of the standard picture. However, our conclusion is optimistic. Humans are rational when human reasoning performance is evaluated in light of the ecological picture. A problem with this ecological rationality objection is that it seems to conflate biological adaptiveness and rationality. For instance, Stanovich writes, evolutionary adaptive behavior is not the same as rational behavior. Evolutionary psychologists obscure this by sometimes implying that if a behavior is adaptive, it is rational. I think a conflation of these interests is at the heart of the disputes between researchers working in the heuristics and biases tradition and their critics in the evolutionary psychology camp. Certainly, it could be biologically adaptive to have a cognitive system that is especially good at dealing with frequencies but not very good at dealing with probabilities. But is such a system not only adaptive but also rational? This issue is closely related to the aim or purpose of cognition, which we will discuss in the next section. Another problem is that the ecological picture seems to imply that humans used to be rational, but they no longer are. The concern, expressed again by Stanovich, is that human reasoning styles probably used to be successful in the ancient environment, but are no longer successful in the current environment, where probabilities tend not to be represented in a frequentist format, and information about cheaters no longer has special biological significance. Unfortunately, the modern world tends to create situations where some of the default values of evolutionarily adapted cognitive systems are not optimal. Modern technological societies continually spawn situations where humans must decontextualize information, where they must deal abstractly and in a depersonalized manner with information. It is therefore, yeah, I mean, you have some abstract number rather than just like the apples on the tree or whatever. It is therefore a challenge to defend optimism even when adopting the ecological picture of rationality. Our temporary conclusion is that none of the objections reviewed so far constitute a serious threat to the pessimistic interpretation of the experimental results. In the next section, we will explore another issue which is closely related to the dispute between the standard picture and the ecological picture. Section 1.6. Can I read that? Oh, I can almost read that even more easily. No, is that true? I don't know. 1.6, the aim of cognition, aiming at truth. Why do we accept the standard picture of rationality rather than, say, the ecological picture? The idea that good reasoning aligns with logical and mathematical rules is often associated with the idea that the aim or purpose of cognition is truth. Because the aim of cognition is truth, the idea that good reasoning aligns with logical and mathematical rules is often associated with the idea that the aim or purpose of cognition is truth. Because the aim of cognition is truth, and because logical and mathematical rules are the best guides to truth, human agents ought to reason in accordance with logical and mathematical rules. But is the purpose of cognition really true? Truth? Does cognition aim at truth? Perhaps Gigerenzer's fundamental disagreement with the standard picture lies in his dissatisfaction with the idea of truth as the aim of cognition. He does not believe that truth is the aim of cognition, or at least he does not believe that it is the only aim.
Adaptive behavior has other goals than logical truth or consistency, such as dealing intelligently with other people.
From this perspective, human reasoning should not be evaluated in terms of logical and mathematical rules. Rather, it should be evaluated in terms of its contribution to biological and ecological success. This takes us to the topic of the aim of cognition, which is the last topic in this chapter. We cannot fully address the issue of the aim of cognition here, but we will identify some considerations that need to be taken into account in a full investigation of this issue. As the aim of cognition is too broad a target for our investigation, let us focus on the mental state of believing and exploring what its aim might be. What does the aim of belief mean? There could be more than one correct answer to this question, but our tentative answer is that the aim of belief is the function of the belief-forming mechanisms. There could be more than one correct answer to this question, but our tentative answer is that the aim of belief is the function of the belief-forming mechanisms, i.e., the mechanisms that produce beliefs in response to some inputs, including perceptual inputs and other beliefs. To say that the aim of belief is truth is to say that the belief-forming mechanisms have the function of tracking truth, i.e., producing true beliefs, avoiding false ones, etc. What does the aim of belief mean? There could be more than one correct answer to this question, but our tentative answer is that the aim of belief is the function of the belief-forming mechanisms, i.e., the mechanisms that produce beliefs in response to some inputs, including perceptual inputs and other beliefs. To say that the aim of belief is truth, it's the function. It's that they function. To say that the aim of belief is truth is to say that the belief-forming mechanisms have the function of tracking truth, i.e., producing true beliefs, avoiding false ones, etc. By function, we mean so-called ideological function. On this understanding, function aligns with evolutionary design. In other words, X has the ideological function of doing Y if X's were selected for doing Y in their evolutionary past history. For example, hearts have the ideological function of pumping blood. Hearts were selected for pumping blood in their evolutionary history. Again, kidneys have the ideological function of filtering metabolic wastes from blood. Kidneys were selected for filtering metabolic waste from blood in their evolutionary history. Thus, our questions are: do belief-forming mechanisms really have the function of tracking truth? And were they selected for tracking truth in their evolutionary history? There are two tempting arguments against the idea that belief-forming mechanisms have the function of tracking truth. Both arguments, in our view, are problematic. Two tempting arguments against the idea that belief-forming mechanisms have the function of tracking truth. Sorry, Tango, you're saying that you do you believe that belief-forming mechanisms have the function of tracking truth? Huh? I don't think Eris thinks that belief forming mechanisms have the function of tracking truth. He's going to talk about the argumentative theory of reasoning, right? Who's that? Slovic or Bloom? It's one of the Pauls. No, it's not. Just look this up. I had Sarah look this up the other day. I forgot. Argumentative theory of reasoning. Oh, Sperber and Mercier. I saw the name Dan. Hugo Mercier and Dan Sperber. That's right. Okay. I was gonna say I thought it started with the D, but I thought that's what I said last time, and it was wrong. Okay, anyway, no worries. Okay, so the first argument is that the function of belief-forming mechanisms cannot be tracking truth because natural selection does not care about truth; it cares only about reproductive success. This argument might seem compelling at first glance, sure it does, but it does not stand careful scrutiny. Sure it doesn't. All right, convince me. The problem with this argument becomes obvious when we run a parallel argument about hearts. The function of hearts cannot be pumping blood because natural selection does not care about pumping blood. Natural selection only cares about reproductive success. Get the fuck out of here. Stop. Stop, Kengo. Uh, Miyazono-san. Get the fuck out of here. Pumping blood. You cannot reproduce without pumping blood. You can definitely survive without tracking truth. Go outside and or look in the mirror and you'll see an example of someone surviving without tracking truth. Nah, cause we're not. Fuck this. We like Donald Hoffman. Fitness beats truth. FBT theorem. Fitness beats truth. Get out of town. We're putting the biggest of yods there. Get out of town. Let's see. All right. Okay. Okay. Convince me. The problem with this argument becomes obvious when we run a parallel argument about hearts. The function of hearts cannot be pumping blood because natural selection does not care about pumping blood. Natural selection only cares about reproductive success. The weakness of the parallel argument is clear. The choice between pumping blood and reproductive success as the function of hearts is a false dichotomy. After all, hearts contributed to reproductive success by pumping blood, which is why the function of hearts is to pump blood. Similarly, the choice between tracking truth and reproductive success as the function of belief-forming mechanisms is a false dichotomy. Perhaps belief-forming mechanisms contributed to reproductive success by tracking truth, in which case the function of the mechanisms is to track truth. Right, perhaps. Big fucking perhaps, bro. The second argument is as follows. The function of belief... So I'm not convinced. The second argument is as follows. The function of belief-forming mechanisms cannot be tracking truth because, as we have seen in the heuristics and biases studies, such mechanisms, and reasoning mechanisms especially, lead to systematic errors and biases. In other words, systematic errors and biases constitute evidence that tracking truth is not the function of belief-forming mechanisms. All right, Kango, you're getting another yod. Get out. Get out. The argument is not compelling either. Systematically failing to do X is perfectly consistent with having the function of doing X. Sure. Sure. Is it? If if people were systematically like falling on a regular basis when they were walking, I would definitely question whether the function of legs is walking or whether we are appropriating legs in for walking. But that's not really their function, and we're just not using them for what their function is. So we are assigning them another function, but I mean, we could assign that to hands, right? To arms. Nobody's saying that the function of arms is to walk. You could definitely walk on your arms, and you would fall a lot, and we'd be like, dang, I'm starting to question whether the function of arms is walking. Maybe we're doing this wrong. Maybe we got it upside down. Get out. For example, sperm has the function of fertilizing an egg. Although most sperm fail to fulfill their function. The function of sperm is kind of not to, the function of all sperm is kind of not to fertilize an egg. It's to send candidates to fertilize an egg. Maybe this is a good point. Maybe you're making a good point here. I got to think about this. This is interesting. Also, you know what? I'm kind of wanting to take a philosophical conceptual step back and talk about what we mean by function. Do we mean like intended activity? Because really, there is no intention in nature. And that would be the philosophical. I've learned a lot from this guy. That would be the philosophical, not the biological question. We have to define what we mean by function and see how we're using that. Function equals intended. No, function equals purpose, but there is no purpose in nature. I think that might kind of undermine a lot here, but we just don't have time. So, although most sperm fail to fertilize an egg, some sperm do fertilize an egg, and so for example, sperm has the function of fertilizing an egg. Although most sperm fail to fulfill their function. Although most sperm fail to fertilize an egg, some sperm do fertilize an egg, and that is how sperm has contributed to reproductive success in its evolutionary history. Similarly, it is possible that belief-forming mechanisms have the function of tracking truth, despite them systematically producing false beliefs. Although these mechanisms often produce false beliefs, it is possible that they do produce true beliefs in many other cases. And that is how belief-forming mechanisms have contributed to survival and reproductive success, at least in their evolutionary history. Let us put this a different way. Most sperm do not fertilize an egg, not because sperm do not aim at fertilizing an egg, but because some failure can be tolerated as long as some sperm successfully fertilize an egg in biologically crucial contexts. Similarly, human belief-forming mechanisms exhibit systematic errors and biases not because belief-forming mechanisms do not aim at tracking truth, but because some errors and biases, even systematic ones, can be tolerated as long as some beliefs successfully track truth in biologically crucial contexts. All right, that sings. Yeah, that sings. I'm not deleting those yods. There's some shit you said that I still think was wrong. I think that. But yeah, no, okay. Sure, we can say that belief forming mechanisms have the function of tracking truth or of contributing to the community's tracking of truth, like with Sperber and Mercier's argumentative theory of reasoning. Okay, okay, okay. Because some even systematic ones can be tolerated. I don't know. I think truth tracking is kind of incidental. It happens to often be a good way of surviving, but I don't know. Do I agree with this? I don't know. Okay. To sum up, the arguments above fail to refute the idea that belief forming mechanisms have the function of tracking truth. In other words, the idea that truth is the aim of belief has not been ruled out yet. Before closing this chapter, we would like to mention a particularly relevant discussion by Ryan McKay and Daniel Dennett. Positive illusions. McKay and Dennett endorse the view that in most cases adaptive beliefs are true beliefs, but there is an exception. Positive illusions, i.e., optimistically biased judgments about oneself. That shouldn't be i.e., that should be e.g., because they're. Oh, yeah, and then he even says see box 1C for a list of the most common positive illusions, and it's going to be other stuff. Oh, no, it's not. No, it's all stuff about positive views of the self. Okay, Uh, but what about like, the I thing, the Gerald Smallberg essay, remember that from This Explains Everything, and about how we like backdate our perceptions to cover up the gaps in our perceptions. That's that you don't want to include that 'cause positive illusions, I feel like that should include that. I get you're defining positive illusions the way you're defining it, but it seems like you should have a more specific sounding term, or more something that, yeah. Hmm. Okay, no. Hmm. Okay. Hmm. According to McKay and Dennett, positive illusions are adaptive misbeliefs. In other words, they are false beliefs that are adaptive in themselves. For example, your positive illusion about your health might enhance your actual health and life expectancy. If McKay and Dennett are correct, truth might not be the function of positive illusions or the mechanisms that produce them. Great. Yeah. I mean, what do you mean if they're right? There definitely are positive illusions. What do you mean if they're right, bro? That's hilarious. Please note that positive illusions are importantly different from errors that are due to the adoption of heuristics. In the case of heuristics, false beliefs are merely tolerated. The errors themselves do not have evolutionary value. However, in the case of positive illusions, and you know what? Donald Hoffman in the case against reality has tons of examples of what I wish could be considered positive illusions, but that are adaptive illusions. Um, all right. However, in the case of positive illusions, false beliefs positively contribute to fitness. The function of positive illusions, or more precisely, the underlying mechanism responsible for positive illusions, is perhaps something other than tracking truth. Dennett and McKay's argument is certainly compelling, but is it really true that positive illusions do not have the function of tracking truth? Is it true that illusions aren't true? That's what I just heard. As Ruth Millikan, what this section is crazy, bro. As Ruth Millikan in 2004 points out, it may be too hasty to draw that conclusion. Okay, let me slow down. For example, it is conceivable that the original and basic role of positive illusions is tracking truth, but they later acquired the other derivative roles of contributing to survival and reproduction in a different way. I thought he was just going to say, but they later acquired the derivative roles of contributing to survival and reproduction. Um, so it's conceivable that the original and basic role of positive illusions is tracking truth, but they later acquired the other derivative roles of contributing to survival and reproduction in a different way, which could interfere with the original function in some cases. Many biological systems? No. Many biological systems ride piggyback on systems developed earlier for other purposes. Systems whose jobs were to distort certain beliefs would have to ride on more general systems whose basic jobs were to produce true beliefs. Another worry is that some forms of optimism involving a denial of existing threats are maladaptive, and the challenge is how to distinguish them from positive illusions. In 2020, people all around the world experienced the devastating effects of COVID 19. Some people seem to firmly believe in their relative safety and immunity. I won't be infected. Even if I were infected, I would just have mild symptoms. Oh, I should have given both of those. I thought there'd be more quotes. Sorry, that was geographist of me. And due to underestimating their personal risk, they also exhibited reckless behavior. For the purpose of survival, denying health threats does not seem to be a good strategy, especially during a global pandemic. We can imagine that our ancestors were more I gotta put Sperber, Mercier, argumentative theory of reasoning. Hello. Um, we can imagine that our ancestors were more frequently exposed to life-threatening diseases and viruses. In that ancient environment, the negative impact of simplistic optimism may have easily outweighed its positive impact. Positive illusions have been conceived as the capacity to respond effectively to threats, not as the denial of those threats, and thus they may be immune from this problem. However, questions remain as to how to distinguish non adaptive optimism from adaptive positive illusions. Yeah, I mean, get out, get out. I mean, what about somebody throws up after eating a fruit from a tree, and then the whole tribe we swear off that tree. Is that tracking truth? We don't actually know why he threw up. And also, which reminds me, like, if belief form mechanisms were about tracking truth, how come it took us so long to come up with science, and how come we're so fucking bad at like taking it seriously? Why the fuck do we have religion, bro? Get out, Miyoto-san. Miyazono-san. Okay, finally, section 1.7 summary. The standard picture of rationality claims that rationality consists in reasoning in accordance with the rules of logic, probability, and decision making. However, studies of reasoning errors and biases, in particular the ones in the heuristics and biases program, reveal that we systematically fail to reason in accordance with the rules of logic, probability, and decision making. Thus, if we adopt the standard picture and take the results of the empirical studies at face value, we draw the pessimistic conclusion that humans are irrational. There are three main objections from optimists, most notably Gigerenzer. 1. According to the feasibility objection, the standard picture fails to take relevant constraints into account. 2. According to the meaninglessness objection, the results of the reasoning studies should be dismissed, in particular the probabilistic ones, because they involve meaningless questions about the probability of single events. And 3, according to the ecological rationality picture. According to the ecological rationality objection, we should replace the standard picture with the ecological picture, which evaluates human cognition not in terms of logical and mathematical rules, but rather in terms of biological success in the relevant environment. None of these objections, however, convincingly refutes the pessimistic interpretation of the experimental results. The standard picture is related to the idea that the aim of cognition is tracking truth. This idea has some plausibility, but there are some interesting cases, such as the case of positive illusions, in which beliefs seem to have a function that is distinct from tracking truth. Okay, and finally, 4 questions, discussion questions. Break up into groups, guys. What do you mean when you say that a person is rational? How do you judge whether a person is rational or not? Discuss. Number 2, What do pessimism and optimism about human rationality have in common? And what sets them apart? Compare and contrast. Number 3, is the standard picture of rationality a good measure of how good human reasoning is? Why? Elaborate. And number 4, to what extent should human agents replace the use of heuristics with the application of the rules of logic, probability, and decision making? Is it even feasible for human agents to do so? Enjoy! Bye!